Hello everybody and welcome back to another video on my channel. Today we will be doing an intro to differential equations. So without further ado, let's move on to the video. So as I said in the intro, we're going to do an introduction to differential equations. But what do differential equations even mean? Basically, those are equations that involve derivatives. So let's say I have the derivative of a function squared is equal to x squared. This is a differential equation, as this involves a derivative. And since not just a derivative, this involves the square of a derivative, or essentially like using a derivative as a function, as the derivative of a function is another function. Now, what will we do to solve this? Well, we'll take the square root of both sides, so dy by dx is equal to x, and then integrating both sides, we get x squared by 2 plus c is equal to y, and that's our answer. We have our function over here. But what if we have multiple derivatives and other stuff? Well, then those require many different techniques. But today, we will not be talking about those. Today, we will be doing a quick introduction, so basically classifying them, and also covering one small technique called solving a differential equation by separation, or separation of variables. So, without further ado, let's move on to those methods. Well, the first thing that we need to do with any new topic is classify it. There are different levels of differential equations. There is many ways to classify them. There are two main types of differential equations: ordinary differential equations and partial differential equations. Now, ordinary is just regular derivatives, like the one over here. Now, partial differential equations have partial derivatives, but this is covered in multivariable calculus, so we will not be covering this for today. Will not be covering. So, how else can we classify these? Well, let's look at the derivative. As we see, we have the first derivative. So, we can say this is of order or degree 1. Order or degree 1. And let's say we had a second derivative or a third derivative, that would be order of degree 2 or 3. And that is kind of like classifying a polynomial. Like, ooh, that's cool. Why not we classify just like a polynomial? And since we just did that over here, it becomes very easy to actually understand. So that's the next way to classify. How many derivatives are being taken? Alright, now we know that. But how other ways can we classify it? Well, we could think, what are we doing to those derivatives in the equation? As you can see here, we're squaring this derivative, so it would not be a linear equation, just like if this was a variable, as you're squaring it. So we could classify it as linear / nonlinear. That's another way to classify this equation, linear or nonlinear. And those are basically the main ways to classify an equation. Now there are others like homogeneous and heterogeneous, I think, or non-homogeneous, and there's also other stuff with the coefficients, but those would be taken in the actual differential equations course instead of actually learning how to classify it, and those are more advanced. So this is really all you need to know for now, whether it's ordinary or partial, how many derivatives are being taken, and what are we doing to those derivatives. So now that we know how to classify them, how do we solve them? One common method is separation of variables. Now, that could involve something like this. Let's say dy by dx is equal to y by x. So, on the start, it might be like, how would we integrate y if we just wanted to integrate? But what if we take this dx and put it on this side and have, what if we had this y and put it on this side and this x and keep it over here and then have the dx go on this side. Well, that would give us dy by y is equal to dx by x, and we would integrate that. And we would realize that the solution to this equation is just y is equal to c times x. Now, that's all good and all, but how do we know that we could use this? This method of just removing stuff to one side versus the other. Well, this is where the chain rule of what I was talking in my previous video, what we were doing. When I covered u substitution, trig substitution, and everything else, I talked about moving the du and other stuff on different sides. Now, that all logically follows from the chain rule, and that's something very, very simple that could be solved quite easily using the chain rule. And I'm not going to show it in this video, but you should definitely check out that video to watch that introduction about the chain rule. So let's do one example, and I think that should be good. Here we have our example. Example 1. dy by dx is equal to 6y squared x. So, without further ado, let's start solving it. Now, what we can do is first, we can bring the 6y squared to that side, or just y squared to that side, and we can bring the dx to the right side. So we get dy by y squared is equal to 6x dx. Now integrating gives us negative 1 by y is equal to 3x squared plus c. Now, taking the reciprocal of that, we get negative y is equal to 1 by 3x squared plus c. And then, taking the negative, we get y is equal to negative 1 over 3x squared plus c. And that's a very simple example. Now, one more thing I wanted to cover in this example is regarding the solution of a differential equation. Do we have an implicit solution or an explicit solution? But what do those terms mean? Well, an implicit solution would be something like this, where you have a constant c that can be determined, or that's just a constant and could associate on different values. An explicit solution would be something like y is equal to negative 1 by 3x squared plus 5. And we would solve this by setting different initial values. So, besides that, I think this video is pretty much complete, and I really hope you learned something from it. I hope you enjoyed watching this video, and if you did, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And besides that, thank you so much for watching this video. Once again, you guys are the best part of what I do. See you in the next one, and bye-bye.